So now we begin the second part of this question, which is fairly the same but with a different stress tensor. As you can see here, we don't have any direct forces applied to the x, y or z axis, but we have something along the xz plane, because this component is sigma zx and this one is sigma xz. So the calculus will be the same. That's why I will not detail them, but I will at least show the beginning of the calculus and then I will show the result. So as you can see, we put the matrix here times this time we will start by for example the unitary vector along the x-axis, and we got something along the z-axis, and this is of course in kilopascals. So the force related to the stress tensor is equal to that 2 times 10 minus 2, which is 20 centimeters, times this stress vector. This is 20 kilopascals. And we will have at the end plus or minus 400 newtons. So now we are doing the same for the forces along the y-axis, so the top and bottom faces. And we see that after the calculus we found a stress vector equal to 0, which means that the force will be also equal to 0. This was fast. Then we will have to calculate the forces along the z-axis, so for the front and back faces. So let me show you the calculus again. This is the matrix, the same as this one, times the unitary vector as usual, and this will be equal at the same amount that we found before, but on the x component, and this is of course in kilopascals. Then we deduce the force, which is equal to the surface times the stress vector, and this is equal to 2000 newtons. So at the end we have two forces, and they are not along one axis only. Of course, we have here two components on the zx plane, which is related to shear. So we will have a shear in the xz plane, like that. Remember that nothing is in the y-axis, so we'll only have something on these faces and these faces. So we have here a shear like that, and here a shear like that.